Yeah, good. So I want to thank the organizers I was going to say for having me here tonight, but of course it's for having us here. And it's not even just me and Kevin. The toddler he mentioned is here too. And she does want to be a scientist sometimes. So in case she joins me up on stage, it's okay, we got this, no panic. That said, thank you again for having us. So I'm a scientist, I'm a neuroscientist, I'm a brain scientist by training, and my background is very much biology. So it's nuclear medicine, it's neuroscience, it's neurology, it's genetics, and whatnot. And I never thought I would be here today talking about food, but I am. And it's actually really a pleasure to tell you why that came to me and why we feel that what we put into our bodies is so crucial for health. And that's really important because we are an aging population. And this is some kind of good news from the world, that we live longer. You know, life expectancy has been constantly on the rise for this past century, and nowadays most people can expect to live very long lives. On the downside, longer lives are not necessarily healthier lives. For so many people, old age really brings about an increased risk of disease, especially brain diseases like Alzheimer's disease, which is the most common form of dementia in the world and the focus of my work. We are facing an Alzheimer's disease epidemic. Of all the challenges to aging in our century, nothing compares to the unprecedented scale of Alzheimer's disease. We currently have 46 million Alzheimer's patients in the world, and this number is expected to triple by the year 2050. So it's really a global health crisis. And just to put it into context, in the United States alone, we're expecting 15 million people in the next 20 years, 15 million Alzheimer's patients in the next 20 years, which is broadly the populations of New York and Los Angeles and Chicago put together, or 2.7 Denmarks in local currency. And this is just in the United States alone. And that doesn't even take into account all the people who are going to have some different form of cognitive impairment. And then there are all the people who are going to have to take care of them. So it's really a problem, and we're broadly unprepared to address it. The major challenge being we do not have treatments for Alzheimer's or brain aging or cognitive impairment at large. Now you may think, well, there are some treatments for Alzheimer's, and sure, we do have them. They're called symptomatic treatments. I believe in Europe, Aricept or donepezil is the most commonly used medication, but we call them symptomatic drugs. And the reason we call them that is that they do kind of work and help with the symptoms for a couple of years, but they can't stop disease progression. So many scientists and many pharmaceutical companies are now working to develop what we call disease-modifying drugs that are literally engineered to work like vaccines, and they're aimed at just removing the pathology from inside your brains. Now the problem is, of all the clinical trials so far, pretty much all have failed. So that really begs the question of what are we doing wrong? How do we need to reconceptualize Alzheimer's in a way that makes it addressable and treatable, at least to some extent? And I do like to think that, as with all problems, our approach to a disease, really to any disease or any issue, is determined by what we understand the problem or the disease to be. And I'm showing here something you might be familiar with. This is the Salem witch trial. So it happened briefly in 1692 in Salem, Massachusetts. A number of women were rounded up and were accused of being possessed by the devil. And that was really based on the fact that they did show an erratic behavior. They were seen dancing at night, or they were exhibiting uncontrolled movements, and their cognition was a little bit off. And the solution back then was to hang them, to have the church intervene and just hang them, and then the whole thing escalated to mass hysteria. But then nowadays, at this point we actually understand that many of these women actually suffered from a brain disease that is called Huntington disease, or chorea of Huntington, that affects your brain nerves and makes you exhibit that kind of behavior. So the solution back then was absolutely unreasonable, and it took centuries to actually understand what to do in that case. So that really brings me back to the question we started with millions of future patients with Alzheimer's disease otherwise worldwide, what do we think Alzheimer's is? And so when I started in this field, which is about 15 years ago, most people understood Alzheimer's as the consequence of bad genes in your DNA, or aging, or both. And it turns out that neither of these alternatives is actually the case. So on one hand, we do have the semi-fiction of genetic determinism. Every time I talk to a new patient, they tell me, I'm concerned because Alzheimer's runs in my family, so I feel like there must be a genetic link. I'm going to get it too. And that really doesn't seem to be the case for most of us. There are some cases of Alzheimer's disease that are genetically determined. There are some genetic mutations that make you develop Alzheimer's. But that really only affects less than 1% of the population. So it is a lot less frequent than ever thought before. So genes are really your destiny. And we should stop thinking about a single gene and rather start really appreciating the polygenic nature of life. Genes work in networks, they work in systems. Some systems make you strong, some systems make you weak. So this is the first thing that we need to keep in mind. The second one being that there's a myth of age-related determinism. So many people feel like if you just live long enough, eventually you are going to get dementia. And that's also not the truth. There's really no linear path for any of us. And getting older doesn't have to be an inevitable slope to dementia. In fact, my research and my colleagues' research has led to the understanding that Alzheimer's is not really an old person's disease. We tend to associate it with old age because the symptoms manifest themselves in old age. But in reality, the brain changes that lead to Alzheimer's start many, many decades before in midlife. And by midlife, I'm not saying 60 years old. Midlife is 40. So Alzheimer's should be reconceptualized as a middle-aged person's disease that really begins long before symptoms occur. And this is basically a visual of what happens. There are three factors that really impact our likelihood of getting dementia as we age. And these are genetics, your genes, the environment we live in, and the lifestyle. And this is really a revolution in the field of neurology. I don't know if you're familiar with the field, but usually everything is genetics and aging and pharmaceuticals. And now we're finally talking about environment and lifestyle, and the choices that we make in their habits and their lives is something that affects our brains. And it's really the interaction of these three factors that determine whether or not you're going to go down the yellow line towards, gentle memory decline. In some cases, people will just age gracefully with their mental capacities intact, or whether you're going to go down the slope towards dementia and loss of independent function. So this is really important because the brain is not the black box that is magically housed inside your skull, but rather is a system, and we're here to talk about systems tonight. So it's really a system that interacts with the rest of your body and also the rest of the world over the course of a lifetime. And it's really technology that made it possible to understand that the brain is interacting with all the many complex systems around it. Probably there are two technologies that are so important to scientists nowadays, and this is the first thing that comes to mind is genomics. And Kevin always says cheap genomics, and I'm always like, why would you say cheap? It's super expensive. But it's actually more affordable than it used to be 10 years ago. And it's not even just genomics, but all the omics that come with that. So it's not just your gene expression, it's also everything else that comes after that. So your proteomics, your transcriptomics, your metabolomics, all these things that we can now measure as soon as a patient walks in the door, which is really a revolution in medicine. And then the other tool is really brain imaging, which is what I do for a living, broadly. And brain image is fantastic because, a patient walks in the door, the first time I see them, I can just have them go inside the scanner, look at their brains. We can leave brain function. We can see whatever happens to their brains over time. And we can really see today if they have the present, if they're showing the Alzheimer's changes in their brains 20 years prior to cognitive symptoms down the line. So we can identify people at risk for disease today, which is really fantastic if you're a clinician or if you're a patient as well. And it's really the combination of these two techniques, so genetic predisposition and a risk, people who are at risk, that revealed how Alzheimer's disease is largely preventable. And in medicine, nobody dares using the word prevention. And I think it's fantastic that at this point we're using the word prevention even in clinics. I'm the associate director of the first Alzheimer's prevention clinic in the United States, and I thought it was very brave of my department to openly talk about prevention. So the truth is that over 30% of all Alzheimer's cases, at least 30%, could be prevented by addressing what we call modifiable risk factors. So broadly, there are risk factors we can't touch. We can't touch your DNA, although CRISPR maybe one day will do that. We can't change your chromosomal sex, and we can't touch your family. If your parents have Alzheimer's, we can't do anything about that. But there are many other things that really strongly influence a risk of cognitive decline and dementia down the line that we can address. They're modifiable, they're treatable, they're preventable. And these are broadly cardiovascular health, diabetes, obesity, depression, smoking. I saw a lot of people smoking in Copenhagen, exercise, intellectual activity, and they underlined diet. Not because I'm interested in diet, but because it really turns out that diet is one of the strongest factors to influence brain aging very early on in life. And that's because diet is so important for your brain. Today, we still associate diets with the way we look, at least in the United States, but I would say pretty much everywhere, and what kind of clothing we fit. But the truth is that diet really changes the body and the brain, both. So in concrete terms, it shapes the way we look, but it really also shapes the way we think. And this is really important to keep in mind because if you've ever studied biochemistry, which I have, it's quite clear that the brain is built on food. Everything that happens inside the brain is really based on what you eat. So the brain relies on food 100% for energy, for functionality, and also for structure. So many of the foods you eat literally become part of the fabric of your brain. So think about it next time you have a brownie, for example. And that's true. It changed my kitchen for sure a lot. The thing about the brain is that it's a very specific, very peculiar organ. It is the only organ of the body that is really strongly protected against everything else. It comes with a barrier. It's called the blood-brain barrier. That broadly blocks out everything that is not made by the brain itself. And when the brain is hungry, it literally opens gates or receptors. It uses a phenomenon called transcytosis to get the nutrients in from the bloodstream. And the brain is very selective. Only very specific nutrients can get in. And I listed them up there. So it's really a handful of nutrients up on the left. And these are glucose, which is a simple sugar, vitamins and minerals, essential amino acids, so some kinds of protein, just one kind of fat, polyunsaturated fatty acids, and I'll tell you what it is in a second, and ketone bodies. Everything else can get inside your brain. So whenever you see books that tell you that you need to eat a lot of fat to keep your brain healthy, that's just not the case, because most fats can't even get inside your brain. And these are cholesterol, saturated fat, trans-saturated fats can get inside your brain, except in kids. Any carbohydrates other than glucose can get in. Non-essential amino acids cannot get in. So this is really important to keep in mind because we know that in principle from biochemistry or neurochemistry, but now technology really allows us to understand the neurological effects of these nutrients and foods as you walk in the door. In many studies, we have done many studies where we measure diet and nutrients in our patients and look at their brains with brain scans. And we have shown over and over again that these fats that can get inside your brain do affect your heart. They increase inflammation for many people, and they really affect the rest of you. So they're also correlated with accelerated brain aging and an increased risk of dementia. And these are trans-saturated fat, too much saturated fat, too much cholesterol. Then we have too much sodium, sea salt, table salt. It gives you hypertension to many, many people, and that also affects your heart and then affects your brain. And then we have too much iron, copper, and zinc. These are transition metals, they're called, and they really increase oxidation inside your brain. They increase the amount of free radicals your brain produces. And there's a sort of rusting effect that just makes your brain age faster. Now to the right, those are the nutrients your brain wants and needs. And they have been associated with a much lower risk of dementia in old age and a much lower risk of cognitive impairment of any sort in old age. And these are omega-3 polyunsaturated fats. So you guys are in a great shape because you have wonderful fish. Fatty fish is really a good source of omega-3 polyunsaturated fats. Selenium is an antioxidant mineral that you can find in Brazil nuts. It's very hard to find. A little bit of copper and zinc is good for you. Too much is not. And then we have vitamin A, C, and E. So these are antioxidants that you get from plants. So eat a lot of veggies every day. That's what your brain says. and B vitamins are really important for a healthy nervous system. Now, this could be a little bit impractical and may lead a lot of people to think, oh, I need to get supplements. But in reality, supplements don't work nearly as well as foods for a number of reasons that I can talk about maybe later. But this is really like comparing the Western diet with the Mediterranean diet in more practical terms. And full disclosure, I'm Italian. I'm biased. I love the Mediterranean diet. And this is broadly comparing a diet that is very rich in fast food, processed food, too much meat and dairy, refined sugar and soda like we have in the United States all over the place. Whereas the Mediterranean diet is more like the opposite. It's like veggie, fruits, whole grains, fish, legumes, and red wine. And then there's, of course, everything else in between, right? The Nordic diet is really somewhere in between. Lots of fish. I saw it's a lot of fried fish. It's pretty tasty. So it's not just us, but I'll show you what I mean when I say that the Mediterranean diet really keeps your brain young. So this is one of our patients. This is a 52-year-old woman. This is a brain. And this is an MRI scan of a brain of a woman who was 52 when she first started working with me in 2014. And this is the way you want your brain to be when you're 52 years old. So basically, if you see these little structures in the middle of the brain, the black ones, these are called ventricles. And you want them to be really nice and tight, because everything that looks black inside an MRI, it means fluid. And you want to minimize the fluid and maximize your brain. So you really want the brain to touch the skull, which is the bone around the brain, and you want your brain to be as big as possible, obviously. So this is a great looking brain. Now in comparison, this is the brain of a lady who was slightly younger. She was 50 years old when she started with us. And she had been following a Western diet most of her life. Lots of peanut butter, lots of burgers. I think you can tell right away that there's something off with that brain. There's a lot more black inside. We call that ventricular enlargement. And it's a sign of atrophy. It's a sign that that brain has been losing neurons. And so the fluid is taking over. There's a lot more brain all over the brain, and also there's a lot more fluid all around the brain, and also in those little structures in the middle of the brain where the red arrow is pointed to, those are the hippocampus, or the memory center of the brain. They're surrounded by black, which means they've been shrinking, and that's called atrophy, and it's really a red flag for future Alzheimer's disease. It's not just about these two women, of course, but we've been working with hundreds and hundreds of patients. And what we really find is that the Western-style diet makes your brain age faster. So if you look at people on Western diets in blue and compare them to those in the Mediterranean diet in red, you can see how the Western dieters show decreasing brain activity over time on top and an accumulation of Alzheimer's plaques at the bottom. So they start accumulating Alzheimer's plaques when they're in their 40s. You don't want that. You don't want to start accumulating Alzheimer's plaques or Alzheimer's changes in your brain that early in life. And if changing your diet can avoid you to do that, can spare you from doing that, I would strongly suggest we all change our diets. So to summarize, technology has allowed us to really see through space, which is through the skull, through matter, which is the biochemistry of your brain, and time, because we can now follow people over time and see what happens to them in relationship with their lifestyle, medical history, and everything else that goes on in their lives. So, what are you going to have for dinner? What would you feed your family, your friends, or even the world at large? It's a really important question, because it really takes a consolidated effort to change bad habits. And this is something we should all think about. I do think a lot about it. I even wrote a book about it. If you're interested in talking more, I'd be happy to connect. And thank you so much for your time.